Why don't we go over this mixing tank problem together? Okay, so let's do it. Consider the large mixing tanks shown in figure 10.2.5. Here are our large mixing tanks. Suppose that both tanks, tank A and B, initially contain 100 gallons of brine. Okay, so they initially have that volume. Liquid is pumped in and out of the tanks, as indicated in the figure. The mixture pumped between and out of the tanks is assumed to be well stirred. Okay, let's take it one step at a time. Let's just read A, and then let's see if we're able to tackle A. Construct a mathematical model in the form of a linear system of first-order differential equations for the number of pounds x1 of t and x2 of t of salt in tanks A and B, respectively, at time t. Write the system in matrix form. Okay, so they said, I don't know what happened here. They said to construct a mathematical model. Okay, so let's just focus on one of the tanks. Let's just focus on tank A. What do we see happening in tank A? Well, first of all, we remember that we used to do these problems with a single tank. With a single tank, we could say that the rate of change of okay, let me say that x1 of t is the rate, no, it's the amount of salt in tank A. Okay, now if I write dx sub 1 dt, I mean the derivative of that amount of salt. So the rate of salt change with respect to time is equal to what? Well, it's always going to be equal to the rate in minus the rate out. What is the rate in? We have 2 gallons per minute going in of pure water. So that's going to be 2 gallons per minute multiplied by 0 pounds of salt per gallon. Okay, can we do the same thing with the other thing that's coming in right here? We have 1 gallon per minute, so we're going to add 1 gallon per minute, 1 gallon per minute, times what concentration? Well, it's going to be the concentration in B. I don't know what the concentration in B is, but let's say that x sub 2 of t is equal to the amount of salt in tank B. These little lines that I put mean read same as above. So this, I can move it a little bit closer down. And then I have, well, I don't know what the concentration from B is, but I can say that it's x sub 2, whatever that will be at that time. And remember, that's just the pounds of salt, the amount of salt. So we want to divide it by the volume of water contained in the tank at that time. Well, they're saying that each water that each tank contains initially, they said it right here, 100 gallons of brine. So I'm going to divide by 100. But now you might ask, well, how do I know that there's going to be 100 gallons at the time, specific time of this equation? Or how can I take into account the fact that there's stuff coming in and out that might change the overall amount of water at any one moment? Well, you'd be right, because we need to consider the fact that there's stuff coming out and there's stuff coming in. So what is the stuff coming out? Actually, let's do the stuff coming in first. We have this guy coming in, so that's going to be plus 2 gallons per minute. And then we have minus 1 gallon per minute, and I'm running out of space here, so I'll move this down so that we get more space. And I think I might need even more space. So I'll write it over here. And then we also have that other gallon that's leaving right here. So minus 1 gallon per minute. Now, you see how the units don't work? The units help you sometimes in these problems. So you know you have to multiply it by some sort of time, and then the units would work. So at any one time, depending on what time it is, we're going to have a different concentration. Now you notice, some of you might notice that this, since the stuff that's coming out is the same as the stuff that's coming in, becomes 0 because it's 2 gallons minus 1 gallon minus 1 gallon. But in general, you want to make sure to account for that, because were the had the rates not been the same, then you would have to put that in. And this summarizes the stuff that's coming into our tank A. So this is our rate in for A. Now, let's do our rate out for A. So our rate out for A, we have this mixture coming out. I'll do it in this color. We have this mixture coming out. So that's going to be, I'll say this is rate in A, rate out of A. That's going to be right here. And so we have 1 gallon per minute, 1 gallon per minute of water. And what's going to come out? Well, whatever the amount of salt in tank A is divided by the amount of gallons that there are at any one moment. They said they both starts with 100 gallon, and then we have to do the same thing that we did above. So we have to say, hey, well, maybe there's 1 gallon going in from the left, 1 gallon per minute, another coming in from the right. Here we're just measuring the volume, but we're not really concerned with the concentration. And then we have minus 1 gallon going out, 1 gallon per minute going out. Well, we have 2 gallons for the first one. So here we have 2 gallons. See right here. And then we have minus another 2 gallons per minute. Okay. So then we close this up. Notice the units, we have to multiply it by minutes, and then it all works out. Now, some of you might have noticed, well, first of all, that I didn't use the color that I said I was going to use. So let me add that up. Good. Now, some of you might have noticed that this 2 plus 1 is 3, minus 1 minus 2, that's 0. So this term goes to 0. This is telling us that the amount of water at any one time in tank A does not change because the sum of the rates going in is the same as the sum of the rates going out. And so we can take these two expressions and we can substitute them in here. And this is for our first tank. So let's do that. We get dx 1 over dt is equal to, well, the rate in is going to be 2 times 0. That's just 0. And we have 1 gallon divided by x2 over 100. And I'll drop the units for simplicity. And minus the rate out, which is x1 over 100. Okay. Well, that doesn't look too bad, does it? And then we want to do a similar process for the, we want to do a similar process. I think I forgot some stuff. Let me check. See, we did this one, but we never modeled this one over here. So you see how we only have this term, one term, two terms, three terms. Where's the fourth? We had four things going either in or out. So we need to have four things in our model as well. And indeed, I forgot this one, the two mixture coming out. So here we're gonna have, let me erase these numbers. Here we're gonna have a minus, well, it's actually gonna be a plus. You might ask why, because this is rate out. So we're implying that it is going out. So we leave it as positive because then we subtract it. Otherwise we'd have to add it. And then we're gonna have 2 gallons per minute multiplied by what? Multiplied by the rate. Sorry, the concentration. So how much salt do we have at any one time? Well, that's x1. Divided by how much volume do we have at any one time? Well, that's just 100. Why? Because we said that the net rate going in and or out of A is 0, as we've seen. So now I can write, actually, that the rate out is -3. Okay. See, because I added this and this together. All right. So that was part A. Part A, actually, yeah, I'll do a single video for this one because we have different letter parts. So to do the other one, we want to do the rate in and rate out for this B as well. So what do we have going in? Well, we only have 2 gallons per minute. So again, I'm going to write here 2 gallons per minute, and I'm going to multiply this by the concentration. I don't think I need parentheses here. I'm going to multiply this by the concentration. Well, what is the concentration? Is the concentration in A. So that's going to be x1 divided by the amount of gallons in A. And we know that they will always be 100 because the net rate is 0. And then we need to subtract the stuff that's going out. We have two things that are going out. The mixture that's going into A, this one right here. So how are we going to write that? Well, first of all, I'm going to say -1 gallon per minute. And then I'm going to say, where is the mixture coming from? Well, it's coming from the tank B. So it's going to be multiplied by the concentration of tank B, which is the amount of salt at any time x in tank B, so x sub 2, divided by the volume in B, which is at any time 100 gallons, because the net rate for this one is also 0. Otherwise, you'd have to do this. So don't neglect that. And then we have another one coming out from the bottom right. It's going to be another 1 gallon per minute. Okay? And it's coming out from tank 2, from tank B as well. So it's still going to have the amount multiplied by the concentration, which is the amount of salt at any time in tank B, divided by the volume in tank B. So now that we have this, I can kind of simplify this and rewrite it as 2x1 over 100, which simplifies to 1 and 50. And then I have minus x sub 2 over 100. And we can put actually minus 2x sub 2 over 100. So because I'm adding these two together, they are similar. So minus 2x sub 2 over 100, which we can also simplify as 1 over 50 by dividing both numerator and denominator by 2. Now that we have this, what can we do? Well, we can rewrite this with the prime notation, which is a little bit shorter, more concise, and then we can rewrite it as a matrix. But remember, we have to see, this has to be first. So I don't think we're ready for the matrix yet. Let me rewrite it so that we don't make any mistakes, because that's not good. So we have dx1 over dt is equal to, I'm going to put the x1 first, negative 3 over 100 x sub 1 plus 1 over 100 x sub 2. Okay? And now I'm going to do the same with my other rates. My other rate is going to be d sub x sub 2 dt. That's going to be equal to what? It's going to be equal to what we had over there. 1 over 50 x sub 1 plus, or minus actually, minus 1 over 50 x sub 1. So now we can see and pick out easily the coefficient matrix. So we can rewrite this whole thing as x prime y prime equals to the matrix negative 3 over 100, 1 over 100, 1/50th, and negative 1/50th. You can't see the negative there. And all of that is going to be multiplied by x sub 1 and x sub 2. So if I write x sub 1 here, I should have x sub 1 prime and x sub 2 prime. I apologize if I confused you there. So now that we have this, we need to solve the eigenvalue problem. So I'll call that part A1 and part A2. So this is part A1, and then we'll solve it. All right? I'll see you next time.